The Sun accounts for about 99.86% of the total mass of our solar system. The Sun's core reaches temperatures of about 15 million degrees Celsius, 27 million degrees Fahrenheit. The Sun generates energy through nuclear fusion, converting hydrogen into helium in its core. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth. The diameter of the Sun is about 1.39 million kilometers, 864,000 miles, making it about 109 times wider than Earth. If Earth were a marble, the Sun would be a giant sphere with a diameter of approximately 15 meters, 49 feet. The surface temperature of the Sun is around 5,500 degrees Celsius, 9,932 degrees Fahrenheit. The outer atmosphere of the Sun, known as the corona, can reach temperatures exceeding 1 million degrees Celsius, 1.8 million degrees Fahrenheit. Solar flares are intense bursts of radiation caused by magnetic energy release on the Sun's surface. The Sun has an average density of about 1.41 grams per cubic centimeter, which is denser than water but less dense than most rocks. Sunspots are temporary phenomena on the photosphere that appear as spots darker than surrounding areas. They indicate magnetic activity. The Sun's magnetic field is responsible for solar wind, which is a stream of charged particles released from its upper atmosphere. Every 11 years, solar activity cycles through periods of high and low sunspot numbers known as solar cycles. The Sun emits light across all wavelengths, including visible light, ultraviolet light, and infrared radiation. A solar eclipse occurs when the Moon passes between Earth and the Sun, blocking all or part of its light. Without the Sun's energy, life on Earth would not exist. It drives photosynthesis in plants and regulates climate. The Sun is classified as a G-type main sequence star, G-dwarf, based on its temperature and luminosity. Solar energy output can vary slightly over time due to changes in sunspot activity and solar cycles. The gravitational pull of the Sun keeps all planets in orbit around it due to its massive size. Each second, the Sun converts about 600 million tons of hydrogen into helium through nuclear fusion processes. If you could fit 1 million Earths inside the Sun, you would still have room left over. Helioseismology is the study of waves on the surface of the Sun that helps scientists understand its internal structure. There are more than a dozen spacecraft currently studying various aspects of our Sun's behavior and characteristics. Solar prominences are large loops or sheets of gas that extend outward from the Sun's surface into space due to magnetic forces. Since ancient times, many cultures have worshipped or revered the Sun as a deity or symbolically significant entity. In terms of brightness, our Sun is classified as a third magnitude star. There are brighter stars visible from Earth at night. The total amount of energy produced by the Sun every second is about 386 billion watts, or 3.86 times 10 to the power of 26 watts. The Sun's luminosity, or brightness, is approximately 400 trillion watts. The Sun's rotation is not uniform. It rotates faster at the equator, about 25 days, than at the poles, about 35 days. The Sun's magnetic field is about twice as strong as that of Earth. The Sun has a solar cycle that lasts about 11 years, characterized by varying sunspot activity. Solar eclipses can only occur during a new moon when the Moon is directly between Earth and the Sun. The Sun emits more energy in 1 hour than humanity uses in an entire year. Scientists believe that in about 5 billion years, the Sun will exhaust its hydrogen fuel and expand into a red giant. On average, the Sun loses about 1 million tons of mass every second due to solar wind and other processes. The Sun's gravitational influence extends far beyond Pluto, affecting objects in the Kuiper Belt and Oort cloud. There are over 100 billion stars in our Milky Way galaxy, but only one is our Sun. The Sun generates solar energy through a process called thermonuclear fusion, which occurs under extreme pressure and temperature. The chemical composition of the Sun provides clues about its formation and evolution over billions of years. Light produced in the core of the Sun takes thousands of years to reach the surface due to constant scattering by particles. The sun's corona is visible during a total solar eclipse as a halo around the moon's silhouette against the sun. It's estimated that around 73% of stars in our galaxy are smaller than our sun, making it relatively large compared to most stars. In ancient Egypt, the sun was associated with Ra, their sun god, who was believed to travel across the sky in a solar boat. Astronomers use solar telescopes equipped with special filters to observe sunspots and other phenomena without damaging their eyes. The first successful measurement of sunlight spectrum was done by Isaac Newton using a prism in the late 17th century. Solar panels convert sunlight into electricity through photovoltaic cells made primarily from silicon semiconductor materials. A typical sunspot can be several times larger than Earth, but has lower temperatures than surrounding areas on the photosphere. The concept of solar time refers to measuring time based on the position of the sun in the sky rather than standardized clocks. Many cultures have myths explaining how day turns into night based on observations of celestial bodies like the sun and moon. The sun's energy output can vary slightly due to its magnetic field fluctuations, impacting space weather and Earth's environment. The sun is about 93 million miles, 150 million kilometers, away from Earth on average, a distance known as an astronomical unit, AU. The sun will eventually shed its outer layers, leaving behind a hot core known as a white dwarf. The sun is classified as a population I star, indicating it has a higher metallicity compared to older stars in the galaxy. The sun's gravity keeps the planets in orbit, while its radiation provides the energy necessary for life on Earth. The ancient Greeks were among the first to theorize about the nature of the sun, with philosophers like Anaxagoras proposing that it was a fiery rock. In Hinduism, the sun is personified as Surya, often depicted riding a chariot drawn by 7 horses. The sun emits more than enough energy each hour to power the entire planet for an entire year if harnessed effectively. During a total solar eclipse, temperatures can drop significantly due to the sudden blocking of sunlight. The ozone layer protects life on Earth from harmful UV radiation emitted by the sun by absorbing most of it before it reaches the surface. A single sunbeam can contain millions of photons, each carrying energy that can be harnessed for various applications. Every second, about 1 billion tons of hydrogen are fused into helium within the sun's core during nuclear fusion reactions. Some scientists believe that studying other stars can provide insights into our own sun's past behavior and future evolution. The sun has been shrinking at a rate of about 5 feet per century due to nuclear fusion processes consuming its core material. In Norse mythology, Sol, or Suna, is personified as a goddess who drives the sun across the sky in her chariot chased by wolves. Solar energy technologies have advanced significantly over recent years, improving efficiency rates for converting sunlight into electricity. The sun's spectrum contains absorption lines that reveal information about its composition and temperature through spectroscopy techniques. In astrology, the position of the sun at an individual's birth is believed to influence personality traits and characteristics in horoscopes. Spacecraft like Parker Solar Probe are designed to study the outer corona of the sun up close and gather data on solar winds and magnetic fields. A solar maximum occurs when sunspots are at their highest frequency during an 11-year cycle, leading to increased solar activity overall. The sun has a powerful influence on Earth, governing not only climate but also biological rhythms such as circadian cycles in living organisms. The sun emits a continuous stream of particles known as the solar wind, which can interact with Earth's magnetic field to create geomagnetic storms. The sun's surface is constantly in motion, with convective currents causing granules that measure about 1,000 kilometers across to form and dissipate. The sun's light spectrum contains a range of colors. When passed through a prism, it creates a rainbow effect known as dispersion. In medieval Europe, the sun was often depicted in art as a representation of divine light or enlightenment. The sun is so massive that its gravity is strong enough to bend light from distant stars, a phenomenon known as gravitational lensing. Solar energy potential varies by location. Areas closer to the equator generally receive more sunlight year-round than polar regions. A solar day is defined by one complete rotation of Earth relative to the position of the Sun, which is about 24 hours long. The Sun's atmosphere exhibits complex magnetic field lines that can lead to phenomena like solar flares and coronal mass ejections, CMEs. The temperature difference between the Sun's surface and its corona remains one of the great mysteries in astrophysics today. Ancient cultures often created calendars based on the movements of the Sun, leading to innovations in agriculture and timekeeping. Some species of plants have evolved to track the Sun's movement throughout the day in a phenomenon called heliotropism. The Sun produces energy at an astonishing rate, equivalent to detonating 100 billion nuclear bombs every second. Observing sunspots has been used historically as a method for tracking solar cycles and understanding long-term climate patterns on Earth. Many scientific instruments are designed specifically for observing different wavelengths emitted by the Sun, enhancing our understanding of its behavior. The heliophysics community studies how the Sun interacts with planetary atmospheres throughout the solar system, including those beyond Earth. As humanity continues to explore space, understanding our Sun becomes increasingly vital for future missions beyond our planet. The Sun's energy output is so immense that it could theoretically power all of humanity's needs for thousands of years without running out. The Sun has a solar cycle lasting about 11 years, during which the number of sunspots and solar activity rises and falls. The Sun's corona is much hotter than its surface, with temperatures reaching over 1 million degrees Celsius, 1.8 million degrees Fahrenheit. The solar system's inner planets, Mercury, Venus, Earth, and Mars, are heavily influenced by the Sun's gravity and radiation. The ancient Egyptians worshipped Ra, the sun god, believing he was responsible for creation and life on Earth. Solar eclipses occur when the moon passes between the Earth and the Sun, temporarily blocking sunlight from reaching parts of Earth. The Sun emits a constant flow of charged particles, which creates phenomena like auroras when they interact with Earth's magnetic field. The study of solar neutrinos helps scientists understand nuclear fusion processes occurring within the Sun's core. Solar energy technologies are continuously evolving, with innovations in materials improving efficiency rates for converting sunlight into electricity. The Sun's gravitational pull holds comets in long elliptical orbits that can take them far beyond Neptune before returning closer to the Sun. Many cultures have created myths surrounding the Sun's journey across the sky, often personifying it as a deity or hero figure. Solar panels convert sunlight directly into electricity using photovoltaic cells made primarily from silicon or other semiconductor materials. The Sun is classified as a G-type main-sequence star, G-dwarf, which is common in our galaxy but has unique characteristics compared to others. In addition to visible light, the Sun emits radio waves that can be detected by radio telescopes on Earth and in space. Research into solar physics continues to advance our understanding of stellar evolution, helping us predict how our own Sun will change over billions of years.